Alright, today we're going to talk about chemical reactions and balancing chemical reactions. There are 5 types of reactions. Synthesis is when we have 2 elements to combine to form one product. Decomposition is when we have one compound that breaks apart to form 2 or more products. And there's an example here. This is basically the opposite of synthesis. Single replacement is when we have one element that replaces another element in the compound. And this can happen in 2 ways. So let's say the single element is a metal, then it would replace the first element here because that would be the metal. So A would combine with C and leave B on its own. And then A here, if it's a nonmetal, would replace C because that would be the nonmetal in the compound. You have B and A together and leaving C on its own. Double replacement, then we have 2 compounds that react, and they do this by rearranging the positive ions. And so here, A and C, you see A is with B and C is with D, and then on the other side, they've traded partners, so A is now with D, and C is now with B. Our 5th type is combustion, and this is when we have a hydrocarbon, which is a compound that has carbon and hydrogen. Sometimes it has oxygen, and it reacts with the oxygen to produce carbon dioxide and water. It makes no difference how many carbons, hydrogens, or possibly oxygens are in the hydrocarbon. The products are always carbon dioxide and water. So let's practice identifying the type of reactions. So here we have sodium phosphate and potassium hydroxide. So we have 2 compounds, so this makes this a double replacement reaction. And then the next one, we have magnesium chloride and lithium carbonate. So again, 2 compounds. That's again a double replacement reaction. Then we have carbon and hydrogen. Right, so that's a hydrocarbon reacting with oxygen. So this is going to be a combustion reaction. Right, and then we have lead reacting with iron 2 sulfate, and then over here the lead is now with the sulfate. So this is an element replacing another element in a compound, and so that makes this single replacement. Next we have calcium carbonate, and that is breaking up into calcium oxide and carbon dioxide. So again, we have one thing that's breaking up into 2 or more products, and so here this would be a decomposition. On the next one, we have phosphorus plus oxygen forming diphosphorus trioxide. So 2 elements combining to form a product is a synthesis reaction. And then we have rubidium nitrate and beryllium fluoride forming beryllium nitrate and rubidium fluoride. So again, we have 2 compounds reacting. That's a double replacement. And then we have silver nitrate and copper. Again, compound and an element. And so now the single element is with another, the negative ion here, and so we have a single replacement reaction. Okay, so next we're going to talk about balancing reactions. We have to write a balanced chemical reaction because of the law of conservation of mass. And the law of conservation of mass tells us that matter cannot be created nor destroyed. And so what that means is the number and the type of atoms that we start with has to be equal to the number and type of atoms that we end up with in our chemical reaction. And as we recall, John Dalton told us that chemical reactions occur when atoms combine, rearrange, and separate. Okay? There are many different methods you can use to balance chemical reactions. My favorite is the Seesaw Method, and basically you just go back and forth from the left to the right until your number of atoms are equal. And so here we have 1 sodium, there we have 1 sodium, and so that's equal. Then here we have 1 bromine, but here we have 2 bromines. And so I need 2 on the left. And so I use what's called a coefficient, which just like in math class is a multiplier. So that means I now have 2 bromines and 2 sodiums. So, but over here we had only 1 sodium. So we have to multiply this one by 2, so we now have 2 sodiums. But that makes us have 2 hydroxides, OHs. But that's alright, because over here we have 2 hydroxides. Excuse me. And then we have 1 calcium on the left and 1 calcium on the right. So this is a balanced equation. So what type of reaction is this? Well, it's a compound reaction with a compound, and so that is double replacement. Alright, so another example. We have NH3, known as ammonia, is reacting with H2SO4, forming ammonium sulfate. And so we balance 1 nitrogen, but over here we have 2 nitrogens, because just like in math class, a number outside of parentheses distributes to everything inside. And so we have 2 nitrogens, so I need a 2 over here to make 2 nitrogens. Well, now that multiplies here to have 6 hydrogens, plus we have 2 more hydrogens here, which makes 8. Again, this 2 distributes inside, so 2 times 4 is 8, and the hydrogens are equal. Then we have sulfate, SO4. I have 1 SO4 on this side and 1 SO4 on this side. And so they are equal. And so this equation is balanced. Now what type of reaction is this? Well, we have 2 things forming 1 thing. And so that type of reaction is a synthesis. Most of the synthesis reactions you'll see will be single elements forming a compound, but occasionally 2 compounds can form 1 compound. Alright, so let's look at some more examples. Here we have carbon, hydrogen, oxygen reacting with oxygen, making carbon dioxide and water. So this is combustion. The best way to balance combustion reactions is to start with the carbon, then do the hydrogens, and do oxygen last, because oxygen is everywhere, so that's the hardest one to balance. So we save that one for last. And so here we have 5 carbons. So over here I need to have 5 carbons. Here we have 9 hydrogens. Over here we'd have to have 9 hydrogens, but we have a 2, so what number times 2 would give us 9? Right, that'd be 4.5. But we can't have halves, we have to have whole number ratios. And so that means we need to get rid of this half. To do that, we multiply everything by 2. So now I have 10 carbons, so I need 10 over here. And instead of 9 hydrogens, we would need to have 18, so we'd multiply that by 9. So then when we add our number of oxygens on the right hand side, we have 10 times 2 is 20, plus 9 times 2 is 18, which gives us 38 oxygens. So we need 38 oxygens on the other side. Here we have 2, plus some number we're going to multiply by 2 here, and all that has to be equal to 38. So if I subtract this over, that means I need 36. So what number times 36, what number times 2 will give us 36? Right, that would be 13. And so we balance with a 2, 13, 10, and 9. This is why we would probably want to use pencil for these. Alright, so next we have lead reacting with H3PO4. And so one element in a compound is single replacement. Right. Now to balance, we have 1 lead. Over here we have 3 leads, so multiply by 3. Now we have our hydrogens. We have 3 hydrogens here and 2 hydrogens there. The best way to balance a 2 and a 3, lowest common multiple, is 6. If we multiply this by 2 and this by 3, then they'll both be 6. Now that means we now have 2 phosphates here, but that's alright, because here we have 2 phosphates over here, and this is balanced. The next one, we have lithium nitride and ammonium nitrate. So we have 2 compounds, that makes it double replacement. Now let's balance. 3 lithiums, 1 lithium. So we multiply by 3. Now that means we have 3 nitrates, not 9. That's just for the oxygen. We have 3 nitrates. The NO3 is 1 unit. We have 3 of those. Over here we have 1 of those, right? And so we need to multiply by 3 to make 3 of them. Now that means we have 3 ammonium ions. Well, over here, that's alright because we have 3 there. And then our nitrogen, we have 1 and 1. And so this is balanced. Alright, take a few minutes to try the next few, and then I'll run through them with you so you make sure you get them right. Okay, so we have sodium bromide, calcium hydroxide, 2 compounds. That's double replacement. Alright, so we have 1 sodium, 1 bromine, 2 bromines. So we multiply by 2. Then I have to multiply over here by 2 to make 2 sodium. That gives me 2 hydroxides, which is alright because we have 2 hydroxides there. 1 calcium, 1 calcium. And then we have NH3 and H2SO4. That is a synthesis reaction. Right, and so then we have 2 nitrogens, and then we end up with 8 hydrogens, 1 sulfate. And that is all balanced. And these are the same ones we just did a minute ago. Oh well. You'll have more practice in class. Combustion for this one, as that ended up being 2 and 13, 10, and 9. And then finally this one, single replacement. And we need a 3 in front of the lead, and a 2 and a 3 there.